हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं। देखिए इस क्वेश्चन में क्या है। टू रेल्स ऑफ अ रेलवे ट्रैक इंसुलेटेड फ्रॉम ईच अदर एंड द ग्राउंड आर कनेक्टेड टू अ मिली वोल्ट मीटर। सो लेट अस सी व्हाट इज द गिवन इन द क्वेश्चन हियर। राइट, टू railway tracks are there and it is and it is insulated from ground and insulated from each other. It is connected to a millivoltmeter. So let us see, it is connected to a millivoltmeter here. Okay, and what is the reading of this millivoltmeter when a train travels at a speed of this? So one train is moving here, you can say like this. Okay, so let us say some train is moving along this. Okay, and the speed is given 180 kilometer per hour. Okay, so along the track, given the vertical component of Earth's magnetic field is given, so you can say like the Earth's magnetic field is given here. So you can say here the Earth's perpendicular, it is given vertical. Okay, so this is the perpendicular magnetic field, you can see it is given in the question. All right. Okay, now it is saying given the vertical, right, it is given the magnitude and the rail separated by 1 meter. So this distance is given 1 meter here. Okay, now it is trying to ask what is the reading of the voltmeter. Okay, let us see here what will happen. See, right, what is given? B is given here. How much? See, 0.2 into 10 raised to power minus 4. Okay, and the speed is given. So let us try to convert this speed in SI unit. So V is given 180 into 5.5 by 18 meter per second. So this will become 50 meter per second. Okay, now you can see across which ends you will get the potential difference. See, right, so right, you can't get the potential difference across these two ends, right, because here the the rod is also, or you can say like here the conductor is moving in the direction of right, the conductor is having the velocity in rightward direction and these two ends is also having the velocity in rightward direction. So these are not making perpendicular to each other. So obviously, right, you will get the potential difference across these two ends, only, right, across these two ends, because here, see, right, here the rod will also be perpendicular to the velocity and the magnetic field are also perpendicular. So here you can see right here the rod, velocity and the field all are mutually perpendicular. So this so this satisfies the condition for the motional EMF. So we'll get the EMF only across these two ends. Okay, so obviously, right, as you all know the formula of motional EMF, because here the magnetic field is not changing with the time, here only the magnetic field is getting cut from the right by the moving train. So we'll get the motional EMF here. So here motional EMF is equal to VBL. So V is given how much? See, 50 meter per second. B is given in the question 0.2 into 10 to the power minus 4, and the length, this length is given 1 meter. So this is 1, all I have taken in SI unit. So see how much is coming, 10 into 10 raised to power minus 4 volt. So we'll get here 10 raised to power minus 3 volt. So we can say like 1 millivolt. Okay. Okay, so the answer is 1 millivolt. Okay students, I hope you understood this question.